Welcome to section 8.1, one-dimensional arrays. This lesson is all about solving a common problem in programming, how to store and work with lots of related values without writing hundreds of individual variables. By the end of this lesson, you will be able to create and initialize arrays, modify array elements, loop through arrays using for and for each loops, and catch and understand one of the Java's most common runtime errors, the array index out of bounds exception. Let's start simple. So far, your variables have stored just one value at a time, an int, a string, a double. That's fine when you only need to track one or two things. But imagine trying to store a list of names. You're just overwriting the same variable every time, and you lose the previous value. Now imagine you want to store every song by a band, let's say 300 of them. You're now going to write string song 1 rainy day, string song 2 forever, and so on. That would be exhausting and impossible to manage. Enter arrays. Java's solution to storing multiple values of the same type in a single structure. An array acts like a container with slots. You give it a size, and each slot is numbered. Each item in the array is called an element. Each has a position called an index, starting at 0. If you need to store 300 songs, you create an array with 300 elements, and each song gets its own index. The array is a container that holds a set of string values, a set of int values, a set of double values, and so on. The elements or items of the array are accessed through a numeric index. Using this index, you can set or get a value from a specific element. Let's break it down. If you declare an array with 10 elements, the valid indices are 0 to 9. Indexing always starts at 0, not 1. So array 0 is the first item, and array.length -1 is the last one. Arrays can store any data type. Integers, doubles, strings, even objects. But all elements in the same array must be the same type. You can also make arrays of your own classes. Student array roster, assign new student 30. Now, each slot can hold a student object. To declare an array, the syntax is type, square bracket, name. For example, int, square bracket, scores. So you want to track temperatures. So double, square bracket, temperature. You've now told Java what kind of array this is, but not how much space it needs yet. There are two ways to declare arrays. Int array prime, which is a preferred one, or int prime array. Both do the same thing, but putting the brackets with the type is generally clearer. Declaring the array is just step 1. You still have to tell Java how big it is. Use the syntax data type, square bracket, variable name, assign new data type, in square bracket, size. This creates an array that can hold size number of data type. You can also split this into steps, but one line is clearer. Int square bracket my int array equals new int square bracket 100. This creates an array that can hold 100 integers. You can also split this in 2 steps, but one line is still cleaner. The first code snippet creates an integer array of ages with 3 elements. The second code snippet creates a string array of names with 3 elements. You want to create and fill the array in one step? Do this. String, square bracket, names, assign, in curly braces, Mary, Bob, Carlos. Int square bracket, ages, assign, in curly braces, 25, 27, 48. No need to specify the size. Java figures it out from the values. Accessing elements. Int age, assign, ages, in square bracket, 1. This gets the second value in the array. Changing elements, names, in square bracket, 0, assign, Gary. In exercise 1, practice recognizing the three parts of array declarations: the type, the name, the size if specified. Try it with int array, my array, assign new int array 20. Char array sentence, assign new char array 100. When you create a new array, Java gives every slot a default value. For ints, 0. For double, 0.0. For boolean, false. For string or objects, null. These default values are placeholders until you assign your own. You want to find the size of an array? Use the .length property. System.out.println primes.length. This is super useful when looping through an array. In exercise 2, create a new project called ArrayX. Declare an integer array scored with 9 elements, a byte array values of size 10 where every element is 1. And comment code in arrayx1.java and fix any syntax errors. Now let's talk about traversing an array, meaning visiting each element one by one. You'll usually use a for loop. For int I less than array.length, I++, system.out.println, array of I. When traversing, using the array's length property helps you to know how many iterations are required. There's also a simpler way, the for each loop. For each loops through every element, no need for index numbers. Just remember, you can't modify array elements directly inside a for each loop. Here is an example of traversing the names array by using a for each loop. In for each loop, the next element is retrieved and stored in an iteration variable, which means you don't have to control the indexing yourself. For each loop versus loop, for loop. Both give you the same result, just in different styles. For each is great for read-only tasks like printing or summing. The slide example shows 4 elements in the names array. The code block executes 4 times, and the name variable holds a different array element each time. Let's put it all together with a full program. Declare a double array scores for 10 students. Use a loop to input their scores. Print all scores. Use another loop to sum them and compute the average. Simple, clean, and practical. In the slide example, the program prompts you to enter one score for 10 students of a class by using the scanner class. The scores are stored in an array called scores. Next, the scores stored in the array are printed to the console by traversing the array with a for loop. Using another for loop, the sum of the 10 scores is computed, and the average score is obtained by dividing the sum by 10. That is the total number of scores. Finally, the average score of the class is displayed. In exercise 3, add compute avg.java to your project. Prompt the user for 5 test scores, store them in an array, compute and print the average. Make sure each test is worth 100 points, easy to validate. Now let's talk about errors. Arrays have fixed size. Try accessing an index that doesn't exist. And Java throws an array index out of bounds exception. Such an error happens at runtime, and it will crash your program if you don't handle it. The error message helps you find where you made a mistake. In the example, we tried to modify an element at position 10, meaning the 11th element, whereas the array only has 7 elements. Therefore, the runtime environment crashes due to this error. In exercise 4, add arrayx2.java to your project. Run it and observe the error. You'll likely hit that out of bounds exception. Fix the code and use a for each loop to display all elements in the array. To wrap it up, arrays let you store multiple values in a single variable. Use indexing to access and change values. Use loops, especially for and for each, to work with all the elements. Watch out for invalid indices. They'll crash your code fast.